Hello class, welcome to the next lesson in 8th grade Eureka Math. We're in Module 4, Lesson 28 today. Lesson 28 I am calling the Elimination Method. It is a way to solve a system of equations, the elimination method. So you'll need pages 347 through 357 of your Module 4 workbooks. We're almost to the end of Module 4. Just like I always do at the beginning of the lesson, remember that if you need to pause the video to copy anything down, pause the video. If you need to go back and re-watch anything, go back and re-watch anything. Remember, sometimes I go a little fast, but I know I can do that because you are in control of the video. So do whatever you have to do to get all your notes. Do whatever you have to do to understand these ideas. Do whatever you have to do to succeed. Let's start the lesson with the vocabulary. We have 3 terms today. First one is systems of equations. This is a term that we've seen, I think, since lesson 24. A system of equations is 2 or more linear equations that are connected. So 2 or more equations that are connected in a system. They go together. They are related. And we show that they are connected. We show that they are a system by putting this bracket in front of them, just like that. So that bracket means we have a system, equations that are connected. And we like to solve this system. Now remember, the solution to the system is a set of coordinates. Coordinates that make all the equations true in the system. Now we've talked about several ways to solve the system. The first way we used was graphing and just using and solving it visually. Graphing both lines and seeing where they intersect, and the point where they intersect, that is the solution. Although we did also see that sometimes graphing solutions is not possible or not easy to do because sometimes they intersect in between integers. They intersect in between intervals, and it is difficult to see a fraction intersection. So we did talk in the last lesson another way to solve, called the substitution method. The substitution method is a strategy to solve a system of equations by using y equals y or x equals x. That means we replace similar terms in equations. Y equals y, x equals x, when we replace similar terms in equations. So we replace the terms, we find one of the coordinates, and then we put it back. We put that coordinate into the equation, into one of the equations, and we find the other coordinate. So the substitution method we did in lesson 27, it was y equals y, or we saw it could be x equals x. But that is one way to solve a system of equations. Today we're going to learn this other way, the elimination method. The elimination method is another strategy to solve a system of equations by canceling one variable to find the other. We cancel out a variable, and that just leaves us with the variable we're looking for. So the way we cancel it out, I gave a little example right here. X plus negative x cancels into 0. And if we cancel out x, we keep y. And that's how we find y. And then we use the y to find the x. Don't worry, we're going to talk about today, we're going to do some examples together. I just want you to write down the vocabulary so you have those explanations. And then I will show you how all of this comes together today. So what we're doing today, we are going to review the substitution method. So I'll practice the substitution method with you a little bit more. So we will review the substitution method, show you some tricks that I did not show you in lesson 26 that in lesson 27. I wanted to save them for you for lesson 28. So we're going to review the substitution method, and we're going to learn the elimination method for solving systems of equations. So that's what we're doing today. We are finding solutions. We're going to use the substitution method or the elimination method to find these solutions. So the first thing I want to do is show you some parts of the substitution method that I did not show you in lesson 27. I wanted you to learn one way of doing the substitution method in lesson 27. Now I'm going to add options for the substitution method today. Let me show you those options. So here's my examples for the substitution method. Examples for the substitution method. So you'll see example A. We have a system where y equals 3x plus 5 and y equals 8x plus 3. Now this is exactly what you saw yesterday. This worked well with the substitution method from lesson 27 because you know that y equals y, and both of these are in slope-intercept form. So all you have to do for this part is you take the first y, 3x plus 5, and that equals the next y, 8x plus 3. Then you use your properties to solve. So like I'm going to do the substitution property of equality, subtract 3x from both sides. That gives me 0 plus 5, which is 5. And 8x minus 3x is 5x. Next, I'm going to do minus 3 from both sides to get the x by itself. That gives me 2 equals 5x. Then I'm going to divide by 5. And that's how I find out that x is 2/5. So in my answer, I know x is going to be 2/5. But because the solution is coordinates, I still need y. So I take the 2/5 and I put it back into one of the equations. So I take y equals 3x plus 5. Does not matter which one you pick. X is 2/5. Because I found it right there. So I put 2/5 for x plus 5. 3 times 2/5 is 6/5 plus 5. To add fractions, I need the denominators to match. So 5 turns into 25/5 because 25 divided by 5 is 5. So that gives, and then I can add 6/5 plus 25/5 is 31/5. So y is 31/5. And that's the solution. That's the substitution method you used yesterday. Y equals y. Just like that. You take both equations and you put them in you substitute them for y equals y. You solve for x, then you solve for y. That's what we did yesterday. Now there are a couple options to make the substitution where the substitution method works a little bit differently. I'm going to show you one of them right here with example B. Example B, you'll see I have a system where y equals 7x minus 2 and 2y minus 4x equals 10. Now, yesterday what I had you do is I had you change this. I had you change both of these to slope-intercept. Today I'm going to show you why you don't have to. You do not have to change. This is in standard form right now. You do not need to change that to slope-intercept. You can keep it in standard form. Let me show you how. Because y still equals y. So what I'm going to do to solve this a little bit faster than we did yesterday. This is faster than what we did yesterday. I'm going to take this y and substitute it right there for that y. So I'm going to have 2y minus 4x equals 10. I don't have to change it to slope-intercept, but what I'm going to do is this y is going to become 7x minus 2. And this part came from over here because this y equals this y. Y still equals y. I'm just taking away a step. I do not have to change this into slope-intercept form. I just say the y equals y, and everything stays in the same place right here. I can still solve this. I did not have to change it. So this might be a little bit of a shortcut from what we did in lesson 27. Lesson 27 was to teach you the basics. Now in lesson 28, I'm teaching you these shortcuts for the substitution method. So let's solve this. I need to use the distributive property first. 2 times 7x is 14x. Minus 2 times 2 is negative 4. Minus 4x equals 10. Now I'm going to combine my like terms. 14x minus 4x gives me 10x minus 4 equals 10. I'm going to add 4 to both sides. So I get 10x equals 14. I'm going to divide by 10. I get x equals 14 tenths, which simplifies to 7/5. So you see how it's the same exact thing, x equals 7/5. I did the same thing up here as I did in example A, just this y equals y. I put the y into the other equation. I put the y inside. Instead of doing y equals y, I put it inside the other equation. You're allowed to do that. You still take the 7/5 for x, and you still put it back in one of the equations to find y. Just like I'm doing right here. 49/5 minus 2, which is 10/5. So I get y equals 39/5. Same exact thing, same process. This is just a way to do it. If you do not, like example A, they were both in slope-intercept form. Example B, we had one slope-intercept and one standard. I still worked. I did not have to change this into slope-intercept. In lesson 27, I told you to change it. Today, you don't have to, because this is how you do it if you don't want to change it. Example C, let me show you another situation where it could work. Right here, we have example C, 5x plus 2y equals 9, 2y equals 3x minus 7. So these shortcuts require you to pay more attention. So one of the things you have to pay attention to right here, the one thing I see when I look at this, I see a 2y in this equation, and I see a 2y in that equation. So for this example, example C, I'm going to know that 2y equals 2y. The 2y here is the same as the 2y there. So what I do is I can just take this equation, and I take the 2y, and I put this expression instead of the 2y. Because 2y equals 2y, I can take this piece and put it there, because 2y equals 2y. This is a shortcut, but it means you have to pay attention to what things are the same. You have to pay attention to what they have in common, a skill that's also going to come in handy when we do the elimination method. So this is 5x plus 3x minus 7 equals 9. So combine the x's, I get 8x minus 7 equals 9. Add 7 to both sides, I get 8x equals 16. Divide by 8, I get x equals 2. First part of my coordinates are done. Now I take the x equals 2 and put it back into one of my equations. Let's do this one. 3 times 2 minus 7. That's 2y equals 6 minus 7. That's 2y equals negative 1. Divide by 2. That means y equals negative 1/2. And that's the answer. So you can see that these are some shortcuts to the substitution method that we learned in lesson 27. So example A was the substitution method when you have two slope-intercept forms. You just put y equals y, you find x, then you find y. Example B, if you have one slope-intercept and one standard, you just take the slope-intercept expression and put it in the standard. Example C, you see something that both equations share, and that's what you substitute. So the substitution method just means you're substituting things. As long as you are substituting equal for equal, you're fine. So look at what the equations have in common. Try to figure out how to a shortcut method. You can always do what we did in lesson 27 and make them both slope-intercept form if you want. But these shortcuts will save you some time. You just have to pay attention and look to see what they have in common. So that's the updated substitution method with a few shortcuts in it. So hopefully that helps you, because you're going to keep using the substitution method today. In fact, today you're going to have to decide what is the most useful strategy. Are you going to follow the substitution method, or are you going to follow what we're going to learn next, the elimination method? So the next thing I need to teach you is what the elimination method is. The examples for the elimination method are actually in your workbook on page 347. you'll see examples for the elimination method right there. So there's 3 examples for the elimination method. The next thing we're going to do is we're going to talk about these, go over them, and see how well you know them. So let's learn this new strategy to add to our substitution method strategy. Okay, so now let's look at some examples for how we do the elimination method. Now this is going to be similar for example C in the substitution method, because you have to look and find what is similar about both equations, or not exactly what is similar, but actually what is the exact opposite in both equations. So what you need to do here is you'll look at this system, and we want to eliminate, the goal is to eliminate a variable. Eliminate a variable. That is our goal. Eliminating a variable is the first step. So looking at these 2 equations in our system, I see that we have negative 5y and 5y. Those are opposites. So if I add them together, it eliminates them. So what I'm going to do is I'm going to add these equations together. I'm going to do 6x minus 5y equals 21 plus 2x plus 5y equals negative 5. I'm going to add these things together. Now you can do this vertically like I just did, or you can do it horizontally. Like vertically is stacking them, horizontally is doing side by side. So what we're doing really is we have equation A and we have equation B. So we do A plus B. We add them together. Well, 6x plus 2x is 8x. And like we said, negative 5y and 5y are opposites. So this negative 5y and 5y turn into 0. And 21 and negative 5 turn into 16. So I get 8x equals 16. The division property of equality, dividing by 8, tells me that x equals 2. So I found x. I found the first part of my coordinates. X is 2. And I did that by eliminating the y. I saw that equation A and equation B had opposite terms that can be eliminated. If I add them together, I eliminate the y terms, I keep the x terms, and I solve for x. But to finish my answer, I need to take this x and put it back in one of the equations. So let's do 6x minus 5y equals 21. And now I have x, so I put the x back in, and my job is to find y. 12 minus 5y equals 21. Add 5y to both sides to get it positive. 12 equals 5y plus 21. Subtract 21 from both sides. That gives me 5y equals a negative 9. So divide by 5 gives me y by itself, and I get y is negative 9/5. That is my solution. And I got that because I was able to eliminate the y term. Now, sometimes you eliminate the y term, sometimes you can eliminate the x term. You just have to pay attention to the equations, and if there is something that can be eliminated, use it. Now, you'll notice both of these were in standard form. I did not even have to think about slope-intercept form. I used these like they were. I used these like they were. Makes it much easier when you eliminate. There's actually less steps, there's less properties you have to use to find x. Then after you find the one variable, like the substitution method, you have to go back and find the other variable. So pay attention and look for something to eliminate. Look for opposite terms in the equation. For another example, let's look at example 2. It's going to be a little bit different because you'll see in example 2, if you're paying attention, you don't see any obvious opposite terms. Like we have negative 2x and we have 4x. Those are not opposites. We have 7y and negative 2y, not opposites. So how do we solve this using elimination? Well, let me show you. Because if you look at these equations, you can change one of them to create an opposite term. Let me show you. Let me actually color code this so you can see it a little bit better. We have negative 2x plus 7y equals 5. And we have 4x minus 2y equals 14. Now, I'm going to change one of these because if you look at this, negative 2x and 4x are kind of close to being opposites. All I really have to do is take the orange equation, 4x minus 2y equals 14, and divide everything by 2. I divide all the terms by 2. That gives me 4x divided by 2 is 2x. Negative 2y divided by 2 is just negative 1y. And 14 divided by 2 is 7. So now my system changes a little bit. The blue equation stays the same. But now the orange equation, I simplified it a little bit. I have 2x minus y equals 7. And now you can see, after I simplified it, the equation is not different. The equation is just simplified. It stays the same because I divided everything by 2. So this equation and this equation are the same line. We learned about same lines a few lessons ago. These are the same line, just different numbers. So, but now, because I changed it, I see opposite terms. So I can combine these. I can do blue plus the orange, equation A plus equation B, and that will eliminate the x term. Let me show you this. We're going to do horizontally. So we have negative 2x plus 7y plus, so I stacked it for example 1. I'm going to write it horizontally for example 2. Plus 2x minus y equals 5 plus 7. I'm adding the pieces together. Now I'm going to use the commutative property to move everything around. I get negative 2x plus 2x. I'm going to put my terms next to each other. Plus 7y minus y equals 5 plus 7. Now you know these are opposites, so these turn into 0. So I get 0 plus 7y minus 1y is 6y. 5 plus 7 is 12. So that 6y equals 12. So y equals 2. Y equals 2. So that's the first part of my coordinates. The y part is 2. To find the x part, I need to substitute the y I know into one of the equations. So I'm going to do 4x minus 2y equals 14. And I'm going to take the y and put it right here. 4x minus 2 times 2 equals 14. That's 4x minus 4 equals 14. Add 4 to both sides with the addition property. That gives me 4x equals 18. So x equals 18 over 4, or simplified, 9 over 2. And that's the answer. 9 over 2, comma 2 is the solution. Now you'll notice this involved a little bit more than example A. Example A, the opposite terms were obvious when we saw them. Example 2, we had to change one of the equations to make the opposite terms obvious. So we changed the orange just a little bit. It's still the same thing. We didn't really change it. We simplified it. We wrote another version of the orange equation. We wrote it in a different form. Same equation, it just looks different. We put another face on it. But after we changed the orange, then we saw what we can eliminate. We can eliminate the x term. So we add the equations together, we eliminate the x term to get y, and then we use the y to find the x. So that's the elimination method. We're finding something to take away. Let's look at another version of the elimination method, example 3 on page 348. Example 3 on page 348, you'll look at this and you'll say, okay, wait a second. I don't see anything here that we can use because 7x and 3x don't go together and -5 and -3 don't eliminate. So, Mr. Baylor, how do we solve this using elimination? How do we solve this using elimination, Mr. Baylor? Because there's nothing that really goes together here. Well, just like in example 2, we changed one equation to make something we can eliminate. In this one, we're going to have to change both to make something we can eliminate. And this is where knowing your math facts and knowing how to make things work comes in handy. So what I'm actually going to do for this one is I'm going to take the top equation. Let's do green for the top one, and I'm going to multiply that by, let's say, 3. And I'm going to take the bottom equation and I'm going to multiply that by -5. Now, that's what I know, and maybe some of you see why I'm doing this, but what happens when we do this? What happens when we multiply the first equation by 3? Multiply everything by 3. Let me show you. Well, 7x times 3 is 21x. Minus -5 times 3 is -15. So we have -15y. -2 times 3 is -6. Now the next equation we're multiplying by -5. So 3 times -5 is -15x. -3 times -5 turns into positive 15y. And 7 times -5 is -35. Now you'll be able to see why I multiplied by these things. I multiplied by these to make something I can eliminate. You can see after I multiplied this equation by 3 and did not really, it's the same line, just a different equation. So it makes the same line. So the equations are the same, they just look different. And these equations are the same, they just look different. But because they look different, because I multiplied by 3 and -5, now I have something to eliminate. I can eliminate the y term. Because when I add these equations, after I put them in different forms, if I add these equations, and I'm copying them down again, I'm going to add them over here. You can see that if I add them, minus 15y and the 15y cancel to be 0. So I get 21x minus 15x is 6x. 6x plus what I eliminated to make 0, and negative 6 and negative 35 are negative 41. So now I have 6x equals negative 41. So I know x is negative 41 over 6. And that is how I find the x value. Now, if I want to find the y, I have to put the x back into one of these equations. So I'm going to just take it into one of these simpler forms. I'm going to do 3x minus 3y equals 7. So I'm going to do 3 times negative 41 over 6 minus 3y equals 7. And I'm going to solve this equation for y. So the 3 and the 6 turn to 1/2. So I get negative 41 over 2 minus 3y equals 7. Let me add 41 over 2 to both sides, plus 41 over 2 plus 41 over 2. That gives me negative 3y equals 41/2 plus 7. That is going to be negative 3y equals 41/2 plus 14/2, because 14 divided by 2 makes 7. So I get negative 3y equals 55/2, and then I need to divide by negative 3. Divide by negative 3. So if you divide by negative 3, you get, I'm going to do it over here because I kind of ran out of room. You get y equals negative 55 over 6. So our answer is, and that was a little bit of complicated fraction math because we had to add, we had to divide fractions. All that are skills that you should have learned in 5th, 6th, and 7th grade. If you still need help with this fraction work that I just did, make sure you reach out to me and I will help you understand where all these answers came from. But that is fraction math. So the coordinates for our solution, negative 41/6 and negative 55/6. Those are the coordinates. That is our solution. That is our answer. And we found it by elimination. This one was a little bit tricky because we had to change both equations. We had to change both equations. But after we changed them, we found something to eliminate. Now, what I would like you to do on your own is try the exercises. The exercises start right underneath us on page 348. And I believe there are 3 exercises. Yes. Exercise 1 is on 348. Exercise 2 and 3 are on 349. I would like you to pause the video and practice the elimination method because for all of these. They tell you that all of these have a solution. So find the solution by eliminating. Now it does say verify by graphing. Verify by using the graph of the system. You do not need to graph to verify. I just want you to use the elimination method to solve these. So pause the video, take a few minutes, try exercise 1 through 3 on your own, and then come back and see if your answers match mine. Okay, so hopefully you took some time to try exercise 1, 2, and 3 on your own. Now let's check your answers. Now I'm looking at this system, 6x minus y equals negative 10, 3x plus 7y equals negative 8, and I see right off the bat a term I can eliminate because I know negative 7y and positive 7y turn into 0. So that's what we are going to eliminate. So let's add them together. Let's add our equations together. And I'm going to do this one vertically. I don't know why, but I tend to like the vertical work a little bit better. You can do it horizontally if you like, but we're going to add these terms together. So 6x plus 3x is 9x. Negative 7y and positive 7y, that's 0. So we eliminated y. Negative 10 and negative 8 are negative 18. So now we only have x because we eliminated y. Let's solve for x. 9x equals negative 18. So x is going to be negative 2. So that's the first part of our solution. To find the y coordinate, we need to take our x and put it back into one of the equations. I don't think it really matters, so I'm just going to do the 3x plus 7y equals -8. You can pick either one. Whichever one you pick, you are going to get the correct answer. You can pick whatever equation you want to substitute x in. But our x goes right here into the equation, and now we have the y variable. Let's solve for the y variable. So we get 3 times -2 is -6, plus 7y equals -8. I add 6 to make that go away, so I get 7y. Addition property says if I add 6 here, I have to add 6 here, so I get -2. Division property, divide by 7 to make the 7y turn into y, and I need to divide by 7 on that side. So my y coordinate is -2/7. And this is the answer. There it is right there. That's what you should have gotten when you used the elimination method. You eliminated the y variable to find the x, and then you put the x back in to find the y. And that is the solution for that system. I hope you got it. Let's see how well you did on exercise 2 on page 349. Checking your work on this one. There it is. Now you'll look at this one and you'll say, well, there's nothing really obvious. Because we have x minus 4y equals 7, 5x plus 9y equals 6, x and 5x do not eliminate, and -4y and 9y do not eliminate. Well, let's make something to eliminate. So I'm going to change one of these equations, and what I'm going to do is I'm actually going to take the first one, and I'm going to multiply everything by -5. That way, 1x turns into -5x, and it makes something to eliminate. So 1x times -5 is -5x. -4y times -5 is plus 20y. And 7 times -5 is -35. So it's the same line, the same equation, I just made it look different. And you can see why I made it look different when I put the other equation back in the system. Because now you'll see we have something we can eliminate. So we can use the elimination method. All I had to do was change the way one of the equations looked. I changed how it looked to make something able to eliminate. So let's add these together. So let's do it the horizontal way this time. I'm going to do -5x plus 20y, and I'm going to add the orange part, and I'll get 5x plus 9y equals -35 plus 6. So you can see I'm adding together the equations. I'm going to move everything around to get all the like terms next to each other. So the -5x and the 5x are next to each other, and the 20y and the 9y are next to each other. So now I can just combine my terms. -5x and 5x, you know that cancels. That's the whole point of this. We eliminate that to get 0. 20y and 9y is 29y, and -35 and 6 is -29. So we get 29y equals -29. So we divide by 29 and to get y, and we divide by 29 to get -1. So our coordinates, we get, our solution is coordinates, and the y part is going to be -1. Now to find the x part, I take the -1 and I put it back into one of my equations. I'm just going to put it back in the top one. X minus 4y equals 7. Only this time the y is going to be -1. So I get x minus 4 times the -1 I got equals 7. So that's -4 times -1 is +4. Then I do -4 to both sides. That gives me x by itself. It's a subtraction property of equality. 4 minus 4 is 0. 7 minus 4 is 3. So x is 3. That is the solution that you should have gotten as well. 3 comma -1 is the solution to this system, and I found it by elimination. I just had to change what one of the equations looked like to find something I can eliminate. Pretty good job if you got it right. If you did not get it right, take a look and see how you're doing. Let's look at exercise 3. Exercise 3, you'll see we have 2x minus 3y equals -5 and 3x plus 5y equals 1. Now, obviously, you can look at the terms and you see 2x and 3x do not eliminate, and -3y and 5y do not eliminate. We are going to have to change both of these to make that, to find something we can eliminate. We're going to have to change both of these. And I'm looking at this, and I already see I have a -y and a +y. So I'm going to multiply the top equation by 5 and the bottom equation by 3 to make the y terms opposites. I'm going to multiply them to make the y terms opposites. Look and see what I do. Hopefully you did the same thing. 2x times 5 is 10x. -3 times 5 is -15, and there's y. -5 times 5 is -25. For the Brown equation, 3x times 3 is 9x. 5y times 3 is 15y. And 1 times 3 is 3. And the reason I did this, you can see right now, the reason I chose these numbers to multiply is now I have something to eliminate. I can eliminate the y term because -15y and 15y are opposites. So let's eliminate these. And I'm going to eliminate it in the vertical style by just stacking them. So I am writing them just like that. And let me add them together to eliminate. 10x and 9x is 19x. The -15y and 15y eliminate to 0. -25 and 3 is -22. So I get 19x equals -22, which means x is going to be -22 over 19. X is -22 over 19. And so that is going to be our x term for our solution. Now I need to find the y term. So I take my x and I put it into one of my equations. So I'm going to pick, let's choose the bottom one. 3x plus 5y equals 1. So I have 3. And remember, the x is what I got, 22 over 19, plus 5y equals 1. So I multiply this, I get -66 over 19 plus 5y equals 1. So now I have to use the addition property of equality to make the 66/19ths go away. I add 66/19ths, that gives me just 5y on the left side. And I have to do 1 plus 66/19ths, which, because it's a fraction, I need the denominators to match, but I just do 19 over 19 because 19 divided by 19 is 1, plus the 66 over 19. So I get 5y equals 85 over 19. And then I don't want 5y, I just want y, which means I need to divide by 5. 5y divided by 5 is y, but I need to divide by 5 on both sides. So that's divide by 5, or it's the same as multiplying by 1/5. if you talk about dividing fractions, you multiply by 1/5 on this side, you multiply by 1/5 on that side. 1/5 times 5 turns into 1, but I have to do the same thing on this side. 19 times 5 is 95. So I get 85 over 95, which can be simplified. It can be simplified, but if you did not simplify it, that's okay, because you have to divide. It does simplify into 17/19. So if you got 85 over 95, you're still good. That's the right answer. If you got 17 over 19, that's also the right answer. I'm going to write 17 over 19 because that is the simplified answer. But that is our solution, and we found it by eliminating. This one was just a little bit more tricky because we had to change both equations to find something we can eliminate. If you did that, you're excellent. You know exactly what you're doing. If you did not, maybe reach out to me for a little bit more help, or you can use the homework helper that is included in the lesson for some more examples. So, page 350 is the lesson summary where they go over the elimination method for you. Again, page 351 is the exit ticket. Let's slide that to the back. And then the homework helper starts on page 353, and I think it's more than one page. I believe it is 3 pages. Yep, it is. They give you some more examples where they show you some equations. They show you how to eliminate, how the elimination method works. So make sure you are using the homework helper for some more examples about all the different types of eliminations that we did. And then when you get to page 357, you get to the problem set. Now, the problem set is going to say, determine the solution if it exists for each system of linear equations. Now, it does say verify your solution on the coordinate plane. You do not need to do that. You're fine. Just find the solutions. Now, for some of these, the solution will not exist because some of them are lines for parallel lines or the same line. So just like in lesson 27, the first thing you need to do is you need to decide, is there a solution? Is there one solution? Is there infinite solutions? Or is there no solution? After you find it, and you only solve the ones if there is one solution. So remember, look at the slopes first. Find the slopes. See if you're going to get one solution, infinite solutions, or no solutions. But if there is one solution, tell me what the solution is. And you can choose. You can use the substitution method, or you can use the elimination method. Whichever way you want to do this, it's up to you. So that's lesson 28's problem set. There are 14 questions where you're going to see if there is a solution. And if there is one solution, find it. Substitution or elimination, your choice. But remember, my answers to the problem set are online. They are on the Google Classroom. So you can check your answers with mine. And you can always reach out to me for some more help. But after you've checked your work and after you feel confident, go to the exit ticket on page 351. There are 2 questions on today's exit ticket. You're going to find the solution to this system and to this system. So find the solution. You can use the substitution method or you can use the elimination method. Look at the system and decide which one makes the most sense. It is absolutely your choice if you want to use the substitution or the elimination. But take a picture of this when you're done. Turn it into the Google Classroom so I can see that you can know how to find solutions to systems of equations. That's your work for today. Like always, if you need anything, please reach out to me for help, and I'll be happy to help you. But work hard, persevere, keep going, don't give up, and have fun.